All right, guess what? It's time for another search and rescue. You know you love them. I won't actually make you do this one this time though, because it's algebraic expressions, and it's been a long time since most of you have probably done that. So we won't actually be going over it, but I just wanted to show you because this one has a little bit of a different format as well. So remember our different number forms, one, they had a different chart where they wrote in the first column was done for them, like you've seen in every one of the search and rescues I've done. And then the second column, they had to write what was on the card. And then the third column, they had to write the missing number form, right? And then in the last search and rescue we did, the first column was filled in for them. Then they did their work in the second column. And in the third column, they put their answer, right? So this one is even a little bit more different. So this one just has the question on the card, a copy of the question on the card, and then a giant spot for their answer and their explanation for why that answer is correct, right? So they could show their work here and explain why their answer is correct. Remember, we're talking algebraic expressions. So they're not actually solving anything, they're figuring out the equation that would go with the word problem. Okay. So that's why the answer would be a little bit different, and they don't really have a whole lot of work to show. They might show how they figured out which equation it is by writing their own and then seeing out of the options which one matched theirs for the answers at the top, right? But they're not going to have like the number 34 as an answer. They are literally just finding the equation that would help them solve the problem. But they did have to also explain why that was the correct equation. Okay, so we'll just start with one. Again, remember, these are just posted on one wall because that's what I have in my guest room slash office. But you would have these posted all around the room. So remember, with all search and rescues, we start at the bottom, right? And the kids can pick whichever one they wanted to start with, or you could assign them groups like we've talked about before. You could color code them. So these are mounted on green construction paper, but you could maybe have each one of them be a different color and then have a purple group, an orange group, blah, blah, blah. And then that's where they start. And then that's how they know they've reached the end. They also know they've reached the end because they're filling out their chart, but they would know they reached the end when they made it back to their own color. So just another idea for how you could do that. So what could be the expression for the following input-output table? It's been a long time since we've done this, huh? So some of us, right? Unless you're teaching in like a 4th or 5th grade classroom. So they would look at this table and then they would figure out. So our first hint is that we have a P and an N, right? So that might tell us something. But anyways, like I said, we are not going to go through this. I don't want to give anyone math anxiety, right? I just wanted to show you a different version. Now, these I made differently. So you've seen the ones where I slid them. I just had them handwritten and I slid them into pocket or page protectors. These I printed on the computer and I just made the equation really, really large in a Word document and then the problem down here. And then I forgot to put the line where I would fold it, so I just drew it. But you could obviously insert a line on Word or just draw it. And then that way it's definite where they start. Maybe you put even like some little arrows or something cute to remind them to start at the bottom. Just another example. Kara earned $42 mowing grass. One weekend she charges $9 per yard and receives some tips from her customers. What expression could be used to show how much she made in tips, right? So we know the total would be 42 and she charges $9 per yard. So it'd be 9N or whatever variable you want to use per yard. We don't know how many yards she did. And she received some tips. So there'd be plus something else, right? So we could figure out which one that is. See, they did it differently than I just explained. So that is actually a perfect example. I didn't look ahead at this, obviously, but that's actually a perfect example of things that there's multiple ways you could write these equations. That's why on the chart, it says which one could be the expression. What could be the expression on a few of these? It doesn't say what's the expression, right? Because I just came up with my own that doesn't match what's up here. But just by using what I knew, I could figure out which one it was, right? It's weird how I have to move my camera for you guys to be able to see. It's opposite of what I would think it is. It's like backing in a trailer. So yeah, there's some different ones. So this is what they did. This is the equation for the carrot one. Because she had $42 mowing grass divided by $9 she charged per yard minus her tips. So they used T, which makes sense. But the equation I came up with in my brain was very different of how I broke that down, and that's okay. And that's actually pretty cool when that happens, because the kids might come to their lifeguard, right? And be like, hey, well, this is the equation I thought it would be. Okay, but I don't see it up there. Okay, you don't see it up there. That doesn't mean your equation is wrong, but what other equation, what else could it be, right? And we find that theme a lot in the way we teach math these days is you might still come up with the same answer at the end of a problem, right? Now we're talking about equations, so we're not actually getting an answer. But that doesn't mean the way you got there was wrong. There's a million different ways to get to that answer. And now we're not even getting to an answer, but there's a bunch of different ways I can set up these equations that would get me to the answer, right? So just a cool little example. I just wanted to show you another way that I do these search and rescues. So like I said, they're mounted on construction paper. They were just typed up in Word, laminated after they were glued onto construction paper. So I hope you guys like this. I hope you're glad that I didn't make you actually solve the problems. Although, you will get to this point, and believe it or not, when you're teaching this stuff, it all comes back to you really quickly, and you will be amazed at the math vocabulary and equations you can just spit off the top of your head. And it actually, teaching math in a funny way, really builds your confidence in math. And I know you guys will all get there, and I'm excited for you because, as you can see, there's so many cool ways to teach math, even though I know some of you are scared to teach it. All right, thanks for watching this video, guys. Comment below what you like, how you might use these search and rescues, maybe what you want to see kind of a spin-off, if there's some ideas you have to spin off of these search and rescues. Obviously, you could do them with vocabulary cards. You could do them with all kinds of things. And I have done them with all kinds of things. These are just the three I still have from when I taught. They're three great examples of different ways you could use it, and even with different grade levels, right? And you could use it in language arts, history. You could put some social studies fact on the bottom and have the year at the top or what have you. So they're great for all subject areas. So I like sharing these ideas with you so you guys can get creative. But I hope you enjoyed this, and I'll see you on the next video.